Hello guys, hello, am I audible? Am I visible? Just let me know whether am I audible or not, then we can start our class. Video audio सब कुछ सही है क्या? एक बार बता दो so that we can start our class. Good evening to all of you. Welcome to our live class. So in today's class we'll be basically discussing about Zeeman effect and Paschen-Bach effect. These two effects are very important for your examination. So in today's class we will be basically discussing about Zeeman effect. Is everything clear guys? Just let me know. Audio video सब कुछ clear है क्या नहीं? So today is 17th of November, मतलब अभी 2 दिन ही बचा है 18th और 19th को, इसलिए मैंने एक क्लास अभी जीमैन इफेक्ट के ऊपर रखा है क्योंकि हर साल हर पेपर में जीमैन इफेक्ट के ऊपर एक क्वेश्चन आता है जरूर। तो अगर आप लोग जीमैन इफेक्ट नहीं किए हो तो दिस वीडियो विल हेल्प यू अ लॉट। सो इन एडिशन टू जीमैन इफेक्ट वी विल आल्सो ट्राई टू डिस्कस दिस पैशन-बach इफेक्ट if time permits. So my name is Sahin Sorifi and I am class educator on Unacademy. I have cleared this exam with CSIR-95 and I am currently a PhD research scholar. If you want to join our Unacademy plus classes, you can utilize our referral code PhysicsHub. So you can get my profile by searching my name Sahin Sorifi and you will get my profile. Once you visit my profile, you will see this is a course for GATE 2021 and it is starting from the next 18th of November. This will be basically batch course for the GATE 2021 aspirants and this course will be taken by Om sir, Anjali ma'am and me. Okay, so it will be starting from 18th of November. So if you have not enrolled for this course, just enroll for this, and if you are not a plus subscriber, you can take it using our referral code PhysicsHub and you can join these classes. Okay, this will be a 3-month batch course that is basically dedicated for this GATE 2021. Another one guys, you will be having your NET exam in this day after tomorrow, means 19th of November. So there is basically a new batch announcement. जो June 2021 batches is starting from the next month, means December 1 से आपका ये batch शुरू हो रहा है for the June 2021 batches. So you can prepare with Unacademy. It's a very good platform and you can just join Unacademy and you can start your preparation for the upcoming June 2021 examination. And other than that, let me just tell you, these are the two courses which are currently ongoing on my profile. I am taking the classes at night from 9 to 10:30 p.m. and currently we are doing this quantum mechanics core detailed course on quantum mechanics on every Monday, Tuesday and Wednesday. And every Thursday, Friday, Sunday we are taking this revision course on physical sciences. So you can just follow these classes. And other than that, if you take an Unacademy plus subscription, you will get a lot of more classes like detailed course on quantum matter physics, you get a practice course on physical sciences, you get a crash course on the most important topics of physical sciences, you get a dedicated course on STR and you also get some course on thermal and statistical physics and a lot of special classes are also there. Okay, so अभी हम लोग शुरू करते हैं क्लास को. Let us just start our class. Let us just start discussing the very important effect, that is Zeeman effect. So we'll start from the very definition, the Zeeman effect. What is basically Zeeman effect? What is this Zeeman effect? So let me just give you the definition first, then we'll try to understand and we'll also solve some problem. So the Zeeman effect is basically the splitting of your spectral lines. Okay, the splitting of spectral lines, the splitting of spectral lines by a magnetic field. Magnetic field is known as, is called the Zeeman effect. Okay, and you see, if this splitting is occurred by this magnetic field, it is called Zeeman effect. If the same effect is observed because of an electric field, that is called Stark effect. Okay, so this was discovered by a scientist whose name is Zeeman and he discovered this effect in the year 1896. Okay, and this Zeeman effect is basically configuration of space quantization. It gives you an idea of space quantization. So what I was saying, if an atom is placed, so you have an atom, okay, and if you place this atom in kind of magnetic field, then the spectral lines of these atoms will be further splitted into several parts, several lines. This effect is known as Zeeman effect. Here you say B equals to 0, and here you say B is not equals to 0. So this line has been splitted into various lines. This effect is normally called as Zeeman effect. And you see the amount of splitting. So note here the splitting, the amount of splitting, the splitting will be proportional to the strength of the magnetic field. The splitting is basically proportional to the strength of the field, of the applied field. So if you increase the strength of the field, the spacing between the different lines, Zeeman, these are called Zeeman lines, spacing between the different Zeeman lines will be more. Okay, now what is the origin? इसके कारण क्या है? The origin of this Zeeman splitting is it arises from the interaction, okay, from the interaction, किसके साथ interaction? Between applied magnetic field, between applied magnetic field, okay, and the magnetic moment, mu, magnetic moment, due to what kind of magnetic moment can be arisen in an atom? It may come from orbital or spin angular momentum, okay, due to orbital and spin angular momentum. So these are two, this is the basic reason of getting the Zeeman lines. I think it is clear till now. Now you see the main thing here is your applied magnetic field. Now depending on the strength of the applied magnetic field, we get two types of effects. Okay, one is weak field effect, another one is strong field effect. So depending on the strength of the magnetic field, we are getting two types of effect. Firstly, we get the weak field effects. Okay, weak field effects where the magnetic field, where you are applying this magnetic field is less, then this weak field effect gives you the Zeeman effect. Okay, Zeeman effect. And there are two types of Zeeman effects. Firstly, we have normal Zeeman effect, and another one is anomalous Zeeman effect. So two types of Zeeman effects are there. It may be either normal Zeeman effect, okay, or it may be anomalous Zeeman effect. Look, the main theory of this Zeeman effect is so simple, but to get to the main formula, we just need to understand it little bit. So magnetic field, it may be weak or it may be strong. So when the applied magnetic field is weak, it gives rise to two types of effect, either normal Zeeman effect or anomalous Zeeman effect. Another one is a strong field effect. Okay, strong field effect means if the applied magnetic field is quite high, then you will get the effect that is called Paschen-Bach effect. The Paschen-Bach effect. I think it is clear to everyone. Now most of the time in your examination, questions are asked from this normal effect or anomalous effect. Paschen-Bach effect से बहुत ही कम question आए हैं, so there is a high chance to get question this time. Okay, so let me just give you some picture so that you can get it understand. So you see, this is the energy level. Energy level has been shown here. Okay, and this was the energy level. Okay, when there is no magnetic field. So in absence of magnetic field, you see this is a single line. Now once you apply the magnetic field, this line has been splitted into two. Okay. Now, as I told you that spin angular momentum is quite responsible. Spin and orbital angular momentum is quite responsible for this splitting. So according to the spin, the levels will be separated. So here you see 1, 2, 3, 4, 5 spins are there. Few of them are spin up and few of them are spin down. And according to their spin orientation, they are separated. You see spin down, m is equal to minus half, it is up, and m is equal to plus half, it is down. So this is a quite visualization of the Zeeman effect. It's a crude representation of showing this Zeeman effect. Got it? Good evening, Bipin. Good evening to all of you. Is it clear till now? Any question? So basically we are covering the theory portion first, then we'll be moving forward to the problems part. Now next thing which we are talking about is polarization of emitted photons. Okay, so let me just add one image. Okay, we are just writing it here. Okay, yeah, so I'm just omitting everything here. So I think you have noted it. The next thing which we are going to discuss is polarization of emitted photons. This one is very important. Sometimes you get questions from this. So depending on the wave of observation, the emitted photons will be different. Like we are considering longitudinal observation. Another one we consider to be transverse observation. So two types of observations are possible, longitudinal and transverse. Okay. Now let me just tell you what is longitudinal observation. So when the emitted photons are seen in the direction of the magnetic field. Okay, in the direction of the magnetic fields, then that is known as the longitudinal observation. Then we'll see that only pi line is found to be absent. Pi line is found to be absent. I will explain it, okay, don't worry. Only sigma plus minus are present and both are circularly polarized. Don't get frightened. ये अचानक से आ गया, इससे देख के frightened मत होना. I will explain it each and everything. Okay, don't worry. We have some picture also for this. So let's say this is the direction of magnetic field. The magnetic field has been applied in the z direction. It's a magnetic field. Okay, and this we are considering the longitudinal observation. So sigma plus minus will be present and pi line is absent. Sigma plus minus. So let me just tell you, this is the direction of k. Okay, this is the direction of spin, and it will be like this. So this is basically your sigma plus line. Another one we have sigma minus line. This is a k. Okay, just hold on, I will explain it. The direction of this is minus h cut. This is your sigma minus line. So this is your left hand circularly polarized, and this is right hand circularly polarized. Okay. So I'm just trying to explain you, depending on the nature of observation, the result will be quite different. So you see, this is the case. The magnetic field direction is this. So if you see in the if you see only longitudinal observation, and then in the direction of the magnetic field, you will get only these two components, sigma plus and sigma minus. But if you are viewing in the direction perpendicular to the magnetic field, that is transverse observation, you see both sigma and pi components. Here you see pi component is absent. pi component is absent. And this, what is this box? Let's say this is your atom, and all kind of spectral transition is happening here because of this magnetic field. Now when you are observing in the direction of the magnetic field, you say that the photons emitted are circularly polarized, sigma plus or sigma minus, but there is no pi component. But when you are observing in the perpendicular direction, this is the direction of the magnetic field and you are observing in this way, so this is a perpendicular direction, and then you see both sigma and pi components are present. That's what I want to tell you. Just watch it in 1080p or 720p, then it will be clear. BP. Now, did you understand this longitudinal and transverse observation, guys? ये समझ में आया? Longitudinal and transverse observation. So you see, in case of longitudinal observation, both pi, sigma plus minus are present, but pi line is absent. In case of transverse observation, all the three components, all three, it is pi, sigma plus minus are present. Okay, and they are not circularly polarized, they are linearly polarized. So this is the direction of the magnetic field BZ. Okay, let's say we are considering this coordinate system X, Y, Z. Okay, so this is the direction of electric field. You see, electric field direction gives you the direction of the polarization. Okay, this is your K. This is your origin. So this is giving you sigma plus minus line, and the pi line is just like this, X, Y, Z. This is your, this is E, this is K, this is your pi line. Okay, so the main thing here is that if you are observing longitudinally, then you only get sigma plus minus component, pi is absent, but when you are observing perpendicular to the direction of the magnetic field, you get all the components, pi and sigma plus minus both. Okay, understood? ब्लर आ रहा है, ये फोटो थोड़ा सा ब्लर है, बाकी और कुछ ब्लर आ रहा है क्या? दिस फोटो इज ब्लर, लिटिल बिट ब्लर. आगे बढ़े. Should I move forward, guys? So first, as I told you, two types of Zeeman effect is there: normal Zeeman effect and anomalous Zeeman effect. This is weak field effect, and in the strong field effect we have Paschen-Bach effect. So we are starting with the very first one, that is normal Zeeman effect. Normal Zeeman effect. Okay, so what happens in normal Zeeman effect? Is it black till now? Nimesha, Bipin, is it black till now, or it is fine? So this normal Zeeman effect is observed between singlet states. What does it mean? Singlet state means 2s plus 1, this is the multiplicity, this is equals to 1. Singlet means 1, and that gives you s equals to 0. So for the atoms whose spin is 0, then those only shows this normal Zeeman effect. Okay, and this is a weak field effect. The magnetic field should be quite low, weak field effect. And for this normal Zeeman effect, we have s equals to 0, and as a result of that, ms is also equals to 0. Okay, so you have j equals to L plus s, so j will be basically equals to L because s is 0, and mj is equals to ml. So what does it mean? That is, it is observed in atoms with no spin. So this is the first one. There are two conditions: it must be weak field effect. Another condition, that the spin should be 0. गुड इवनिंग। ब्लर क्यों आ रहा है? मुझे तो सही दिख रहा है। Just increase your resolution because I am also viewing it from my mobile and it is coming clear. Just go to that triple dot. Okay, in the place of quality, just select 720p or 1080p. Then it will be clear, I guess. Because in my mobile it is appearing to be clear. Just increase the resolution. The resolution at which you are watching, just increase that. Okay. So look, let's talk about the selection rule in the transition of this normal Zeeman effect. So selection rule you can just write in this way: delta ml should be equals to 0 plus minus 1, but ml equals to 0 to 0. This is not possible. Okay, if delta L equals to 0. Now there are three things. The singlet state, singlet spectral lines viewed normal to the field is splitted into three lines. Okay, in case of normal Zeeman effect, it is the spectral line is splitted into three plane polarized components. Plane polarized components. तीन आपका प्लेन पोलराइज्ड कंपोनेंट्स में ये डिवाइडेड हो जाएगा। पहला जो होगा ए सेंट्रल अनशिफ्टेड लाइन। ओके, द फर्स्ट वन इज अ सेंट्रल अनशिफ्टेड लाइन, सेंट्रल अनशिफ्टेड लाइन विथ E vector parallel to the field, parallel to the field. That is your pi component. And other two other lines equally spaced on either side of E vector. Perpendicular to B field. Those are sigma components. So if you can be sure that the atom is showing normal Zeeman effect, then you can directly choose the option 3. It will be divided into three components. One of them will be pi component, another two will be your sigma components. Okay, now let me just give you some mathematical formula which will be utilized to solve problems. Okay, is the electric field, you know that polarization vector is denoted by this E vector. Polarization क्या denote किया जाता है? E से denote किया जाता है. Okay, so when you are considering some photon, it is denoted by E. The polarization vector is denoted by E. So we have total three components in case of normal Zeeman effect: pi and sigma. Now let me just give you some idea about the splitting. So what will be the amount of splitting? So till now I have told you that the single line will be splitted into three lines. So now what is the amount of splitting in your normal Zeeman effect? ये आपके एग्जाम में आता है, ठीक है? So let's talk about the amount of splitting in normal Zeeman effect. The formula is basically, it's a generalization of the anomalous Zeeman effect. Anomalous Zeeman effect is more general than this. Here we are considering those atoms whose spin is 0. So delta E, the energy separation between different components, is given by H into EB by 4 pi m. Okay, and you know this delta E is given by mu B into B. So I'm just writing the separation. So you know that in the separation is represented in terms of wave number. So separation of Zeeman components. What I am telling you, like in the absence of B, this is the line. Now let's say it has been splitted into three equispaced line. Okay, so this spacing is same. this spacing is same between the different Zeeman lines. So this separation of Zeeman lines is given by delta nu bar. Okay, delta nu bar in terms of wave number, this is equals to EB by 4 pi MC. Okay, this is nu bar equals to nu by C 1 by lambda. So EB by 4 pi M into C. Okay, delta E equals to H delta nu, so delta nu by C, EB by 4 pi MC. And just remember this value. You see, one thing, if you can remember this, value of the electronic charge is fixed, pi is fixed, 4 is fixed, mass of electron is fixed. Okay, and C is the velocity of light, C is also fixed. So you can just remember this formula. This will help you a lot if you can remember. Otherwise, you have to evaluate this in your NET examination. But you know, in NET examination, calculator is not allowed. So it's better if you remember this value, 46.7, and this B, it is in meter inverse. Okay. So if you remember this, it is well and good. Otherwise, you have to calculate it at your examination hall. So now nu equals to C by lambda. So from here we can calculate delta nu. Delta nu equals to minus C by lambda square delta lambda. So the separation between the different Zeeman lines in terms of wavelength delta lambda, it is basically lambda square upon C into delta nu. Okay, and this is equals to delta nu by C is this EB by 4 pi MC. Okay, EB by 4 pi MC into this lambda square. Okay, so delta nu equals to basically, so we have to utilize whatever formula is utilized for a particular problem. So I am just giving you all the formulas, okay, which may be required to solve the problem. So here we have got the three formula. Basically, this is the wavelength, the separation in terms of frequency, this is the separation in terms of wavelength, and this is the separation in terms of wave number. Now depending on the question, whatever information it is asking in the question, you will be utilizing the formula. So I am just naming it. This is in terms of wave number, this is the separation in terms of frequency, this is the separation in terms of wavelength. So ये तीन formula आपका normal Zeeman effect का है regarding the splitting. So if it is done, we can move forward to some problem. ये तो क्लियर ही आ रहा है, पता नहीं आप लोगों को क्यों क्लियर नहीं दिख रहा है, मुझे तो एकदम दिख रहा है. Just increase the quality guys. Streaming quality आप लोग थोड़ा सा चेंज कर लो, क्योंकि मेरे मोबाइल में भी स्ट्रीमिंग हो रहा है लाइव एंड इट इज कमिंग क्वाइट क्लियर. एनजे फिजिक्स, शुड आई मूव फॉरवर्ड फॉर ए प्रॉब्लम? एक प्रॉब्लम कर लेते हैं हम लोग. सो इफ इट इज डन, वी कैन जस्ट मूव फॉरवर्ड टू ए प्रॉब्लम. इज देयर एनीवन हु कैन सी द राइटिंग क्लियरली? किसी को क्लियर दिख रहा है क्या? अमर ज्योति, ओके. सो देखो, अकॉर्डिंग टू मी क्लियर है, और आप लोग कोई एक अगर बोल रहे हैं क्लियर है, मीन्स द फ्रॉम द सोर्स देयर इज नो प्रॉब्लम. तो आप बस वो स्ट्रीमिंग क्वालिटी, वहाँ पे अगर मोबाइल से आप देख रहे हो तो वहाँ पे देखो क्वालिटी बोल के एक ऑप्शन आएगा, उसमें आप देखो कितना पी पे सेट किया गया है. यू सेट इट आइदर 720p 60 और 1080p 60. So I am streaming in 1080p 60. That is a very high quality streaming. Okay, so I don't think it should be blurred. Okay, तो एक प्रॉब्लम हम लोग कर लेते हैं. मैं थोड़ा सा बड़ा करके लिखता हूँ ताकि आप लोगों को थोड़ा सा आसानी हो. An atomic transition 1p से 1s in a magnetic field. What is that magnetic field? Amount of magnetic field is 1 Tesla. Tesla is the unit of magnetic field intensity. Okay, I'm just writing Tesla. Shows Zeeman splitting. Okay, given that So I have forgotten to tell you that you know it very well. Mu b is the Bohr magneton. You know it, I think. This is known as Bohr magneton. Okay. So Zeeman splitting, given that the Bohr magneton mu b, इसका वैल्यू है 9.27 into 10 to the power minus 24 joule per Tesla, and the wavelength भी आपको दे रखा है corresponding to the transition is 250 nanometer. मतलब लैम्डा आपको दे रखा है in terms of nanometer. You have to find out the separation. Okay, the separation in the Zeeman spectral lines. Zeeman spectral lines is approximately. So depending on the options, you have to utilize the formula. So you see the options are given in terms of nanometer. So आपको wavelength वाला formula यूज करना पड़ेगा. पहला ऑप्शन है 0.01 नैनोमीटर, दूसरा ऑप्शन 0.1 नैनोमीटर, the third option is 1.0 nanometer, and the fourth option is 10 nanometer. You know nanometer is 10 to the power minus 9 meter. This came in CSIR-NET December 2014. So just solve this question and just let me know what answer you are getting. Okay. Good evening, Soumya, Anjali. Good evening. Good evening to all of you. Just try to solve this question and let me know what answer you are getting. देखो, अगर आंसर आपका एग्जैक्ट नहीं आ रहा है, then you can choose the most closest answer. Okay. Very often in your CSIR-NET exam, options are given, and you get some answer which are not exactly matching with any of the answer. In that case, you have to select the closest option given in the question. Okay. तो ये क्वेश्चन में भी ऐसा ही कुछ है, आपको एग्जैक्ट नहीं मिलेगा. You have to choose the closest answer among the given options. बताओ, you can write the answer in the comment section. यहाँ पे तो Unacademy ऐप की तरह वो पोल के ऑप्शन नहीं है, so you have to write the answer in the comment section. Okay guys, what is the answer you are getting? This is the formula I have already given you. Okay. देखो EB by 4 pi m, इसको क्या है, यहां से निकाल सकते हो. EB by 4 pi m equals to mu b. From this expression you can just write EB upon 4 pi m equals to mu b into b by h. Okay, then you can utilize that formula. What answer you are getting? So you see here we are having the transition from 1p to 1s. So what is the multiplicity? 1. So 2s plus 1 is given to you as 1, and from here you see s equals to 0. So s equals to 0, it prompts us to decide that this is the case of normal Zeeman effect. Okay, this is the case of normal Zeeman effect. Okay. So in case of normal Zeeman effect, we have seen that this delta lambda क्या होता है? Delta lambda equals to, because this is given in terms of nanometers, we have to utilize this formula, EB by 4 pi mc into lambda square. Now EB by 4 pi m equals to mu b into b by h. Okay, So lambda, this becomes lambda square upon c e by 4 pi m equals to mu b into b upon h. Okay, so delta lambda we can directly utilize this formula to get the separation between the different Zeeman lines. So delta lambda equals to, I'm just writing on the other page so that you can understand. यहाँ पे तो खाली जगह नहीं है. So delta lambda is basically lambda square by c into mu b into b by h. So lambda का वैल्यू 250 नैनोमीटर दे रखा है. 250 into 10 to the power minus 9 meter whole square. Mu b, the value of mu b also given 9.27 into 10 to the power minus 24 joule per Tesla, and value of magnetic field is 1 Tesla, so 1 T, divided by the speed of light in vacuum 3 into 10 to the power 8 meter per second, and the value of h is 6.626 into 10 to the power minus 34 joule second. So if you evaluate this, you will get approximately 3 into 10 to the power minus 12 meter. Okay, so we can just write it 3 into 10 to the power minus 3 into 10 to the power minus 9 meter. 10 to the power minus 9 meter is 1 nanometer. So 3 into 10 to the power minus 3, so 0.003 nanometer. Okay, so you see this option is not matching with any option, but it is closest to this option A. So option A is the correct option. You have to choose the option A. So answer for this question is option A. Is it clear to everyone? अंजलि 0.1 आ रहा है ना, 0.01. आगे बढ़े गाइस. Is it clear? Just write Y if it is clear. Now I am going to show you the transitions. अभी हम लोग आपको दिखाएंगे कि ट्रांजिशन कैसे कैसे होते हैं यहाँ पे. So I think it is clear to everyone. Now we are just taking one example, 1D2 to 1P1. This transition we are considering, and we will see what are the components we are getting. Okay, so here you see L equals to 2, SPD, so 0, 1, 2, and this is L equals to 1. Okay, SP, so 0, 1. So this L equals to 2 will be broken up into 5 components, twice L plus 1, that is 5, and this will be broken up into 2 components, twice L plus 1 equals to 3. ठीक है, 3 components में यह divide हो जाएगा. So this is your 1P1, this is your 1D2. So when there is no magnetic field, this is the situation. Okay, now when we apply the magnetic field, so 1D2 will be split into 5 parts, as I have already told you. 2, 3, 4, 5. Okay, because corresponding to one value of L, there are values 12 plus 1 values of ml. Okay, 12 plus 1 values of ml, and that goes from minus L to plus L. Okay, so we are just writing ml values. So it will be plus 2, plus 1, 0, minus 1, minus 2. Similarly, it will be splitted into 3 parts. Okay, and 3 plus 1, 0, minus 1. Okay, now we'll observe the transitions, keeping in mind the selection rule. Delta, what is the selection rule? Delta ml equals to 0 or plus minus 1, but 0 to 0 transition नहीं होगा. ठीक है? So this is the situation when we are getting a single line, that is in the presence of no field, means when we have B equals to 0. Now when we have applied some magnetic field, B not equals to 0, so here we have the field present. इंक्रीज द रेजोल्यूशन गाइज, ये तो क्लियर दिख रहा है, पता नहीं आप लोगों को क्यों नहीं दिख रहा है। So we can consider the transitions here. You see, let me just draw the transition. Firstly, +2 to +1. So what is delta ml? Delta ml equals to 1. Then +1 to 0, it is 1. Okay, -1 to -1. Sorry, 0 to -1. So this is giving you plus line, sigma plus. Okay, here delta ml equals to -1. Then you get from 0 to 0. Okay, so from 1 to 0, I'm just taking another color. So +1 to +1, there delta L equals to 0. 0 to 0 is not possible, so we have to take -1 to -1. Okay, and you see this 0 to 0 transition is not possible when delta L equals to 0, as I told you earlier. You see, the ml equals to 0 to 0 is not possible if delta L equals to 0. But here you see delta L is not equals to 0. Here delta is equals to +1, so 0 to 0 transition will be present here. So this is corresponding to delta ml equals to 0. Then you get -2 to -1, एक another transition आप देखो, -2 to -1. Okay, then -1 to 0 और 0 to +1. So यहाँ पे आपका डेल्टा ml की वैल्यू होता है +1, यहाँ पे 0, यहाँ पे -1. So for 0 you get this line, this is corresponding to the pi line, and these two lines corresponding to the sigma lines. Okay, so this is your pi line and these two are your sigma lines. Delta ml अगर 0 है, that gives rise to pi lines. Delta ml equals to ±1, this gives two symmetrically placed sigma components. You see, although the total number of transitions is 9 here, you get only 3 lines. Okay, so this is a perfect example of normal Zeeman effect, and I have already shown you the transitions. Is it clear guys? Is this thing clear? सबको क्लियर हो गया ट्रांजिशंस वगैरह? Should I start anomalous Zeeman effect? Any question from this normal Zeeman effect? If there is no question, we can go for anomalous Zeeman effect. So in normal Zeeman effect, what points you should remember? That the field given to you should be weak and the S value should be 0, and the total number of transitions in presence of magnetic field, total number of lines we should say, that is will be 3 fixed. So here we are considering this transition 1D2 to 1P1. So our first task to recognize a normal Zeeman effect is that we have to find out S equals to 0 or not. So here you see this is the multiplicity, जहाँ ऊपर जो चीज है that is multiplicity. Multiplicity is 2s plus 1. If it is 0, if it is 1, it leaves us to S equals to 0. S equals to 0, and we are considering a weak field. Okay, weak field, S equals to 0, so this will give you normal Zeeman effect. So we should expect 3 lines, as I have already told you. Now here in this example, I have just shown you the transitions. What are the possible transitions that is giving rise to 3 lines? One is pi line, another 2 is sigma lines. Okay, so here we are seeing 9 transitions. So the transitions which are corresponding to delta ml equals to 0, those transitions are giving rise to pi line. Delta ml equal to ±1, those lines are giving rise to symmetrically displaced sigma component. You can ask that there are 9 transitions, then why we are getting 3 lines? Can do anyone know about this? We are seeing 9 transitions, but we are only observing 3 lines. What may be the possible reason for this? Zero zero, because look, as I told in the selection rule, यहाँ पे देखो selection rule क्या बोल रहा है? Delta ml equals to 0 to 0 is not allowed if delta L equals to 0. But in this particular example, you see, delta L is not equals to 0. What is delta L? Delta L equals to 2 minus 1. So 1 minus 2, that is not equals to 0. So that is why ml to यहाँ से यहाँ तक आप ट्रांजिशन ले सकते हो. अगर if in place of p it were d, then we could have not taken that 0 to 0 transitions. Okay, अगर L वैल्यू चेंज नहीं हो रहा था तब हम लोग 0 to 0 ट्रांजिशन नहीं ले सकते. बट यहाँ पे देखो L वैल्यू D से P तक हो रहा है, तो L वैल्यू चेंज हो रहा है, so we can consider this transition from 0 to 0. Weak field range, basically there is no range, मतलब वैसा कुछ particular range नहीं है, but in your examination it will be mentioned that it is weak field. Weak, that word weak will be mentioned, or it may be given 1 Tesla, 2 Tesla, 3 Tesla, like very small magnitude. Okay. So I think it is clear to everyone. Now let's start anomalous Zeeman effect. ठीक है, तो हम लोग शुरू करते हैं anomalous Zeeman effect. Increase the quality, guys. क्या बोलूँ मैं, मेरे मोबाइल में तो constantly सही दिख रहा है. Degeneracy is the reason. The reason is, as I told you, the interaction energy. In the very first slide, I told you the reason of this Zeeman effect. वो तो गायब हो गया. The Zeeman effect arises because of the interaction between the magnetic field and the magnetic moment of orbital motion and spin angular momentum. Okay, so these transitions, this splitting is coming because of that interaction between the magnetic field and the magnetic moment, and it follows some selection rule, which is delta ml equals to 0 plus minus 1. Okay, so delta ml equals to 0 if we get such transition, that gives rise to pi lines, and if it is plus minus 1, that gives rise to sigma lines. Okay, हम लोग पहले ये सारी चीज बता दिए थे. Okay, for anomalous Zeeman effect, this is also a weak field effect. Okay, this is also a weak field effect, and here S is not equals to 0. This is the basic difference between normal Zeeman effect and anomalous Zeeman effect. So the number of splitting is different than 3. In normal Zeeman effect, the number of components were 3 all the time, but here it is not 3. And here the energy separation delta E between the different lines is given by this formula, G into EB by 4 pi m H delta mj. Okay, so in the previous case J equals to L because S equals to 0. देखो J equals to L था because S equals to 0 था, but here J is not equals to L, but it will be L equals L plus S because S is not equals to 0 here. That's why in place of delta ml we are just writing delta mj. And what is G here? G is the Landé-G factor. Okay, Landé-G factor, and the value of Landé-G factor is very important. ये आपके एग्जाम में पूछा भी जा चुका है एक बार. 1 plus J into J plus 1 plus S into S plus 1, okay, minus L into L plus 1 upon 2J into J plus 1. This is the value of the Landé-G factor, and this is the separation in terms of anomalous Zeeman effect. And here the polarization of the transitions Here's the polarization of the transitions follow the same pattern as the normal Zeeman effect. Okay. Now, as I told you in the earlier case that we got two observations, longitudinal observation and transverse observations. So in longitudinal observation, what are the different components we'll be viewing? Okay. So in case of longitudinal observation means parallel to the magnetic field. So I have shown you this figure. You can see this figure. Parallel to the magnetic field, if this is the direction of the magnetic field B, and if you are observing in this direction, this is known as parallel observation, and if this is the magnetic field direction you are observing in from this direction, that is the transverse observation. So we are firstly considering the normal observation with longitudinal observation which is parallel to B. Here what will happen? Here क्या हो रहा है? Delta mj equals to 0. In those cases, transitions are absent. And if delta mj equals to plus minus 1, then we'll have sigma plus minus. This will be circularly polarized. As you have already discussed about this, so we are just telling you the rules. If you have delta mj equals to plus 1, that will be right circularly polarized, and if delta mj equals to minus 1, this will be left circularly polarized. Okay, EJ SFs J. Line reducing. Okay. I did not get your point. तो उसका जो आंसर होगा, मैंने आंसर तब नहीं दिया ना. Like let's say we are considering 3 transitions. Okay, this one is giving you, let's say, 500 nanometer. This one is giving you 500 nanometer. This one is giving you 500 nanometer. So although we are observing 3 transitions, but all of them are corresponding to the same line. Na? So once 500 nanometer, again 500 nanometer, again 500 nanometer, the position is fixed. So that is why you are getting a single line in place of 3 different lines. Okay, because the separation delta mj equals to fixed. So although it is 3 transitions coming from 3 transitions, we are observing 1 line because that is the 1 line. Okay. I think it is clear now. So in your examination, this is the actual transitions, actual 3 transitions, but this is the observed result. What you are observing is you are observing only 1 line, but physically 3 transitions are occurring. But although the value are same, it's like आप क्या कर रहे हो कि 3 आपका कलर है, 3 कलर एक ही, सॉरी मतलब एक आपका ऐसा रॉड है मान लो, and you have colors, okay, colors from 3 different pots, and all of them are green. If you are coloring this rod first green, second with green, third with all another green, then ultimate result it will be observed as 1 line. Okay, green ही दिखेगा आपको, समझ रहे हो? So this is the case for longitudinal observation, means parallel to B. So delta mj equals to 0, transitions are absent. Delta mj equals to plus minus 1, transitions are present, and those will be circularly polarized. Remember this one. ये आपके एग्जाम में आ चुका है. Delta mj equals to 0 के केस में transition, there will be no transitions. Now let's talk about the next thing with transverse observation. Transverse means perpendicular to the magnetic field. Perpendicular to B. Then what will be the rules here for transverse observation? it will be delta mj equals to 0, then transitions will be linearly polarized along the z axis. Okay, that is z axis wise हम लोग magnetic field apply किए, so this is parallel to B. Next, if delta mj equals to, if you observe, plus minus 1, then transitions are linearly polarized in the xy plane. Linearly polarized in the xy plane. That is perpendicular to B. Okay, so this figure will help you to understand exactly the situation. This figure. So when you are observing in a transverse direction, you see one component, pi component, it is parallel to this magnetic field, but this sigma component is perpendicular to magnetic field. This direction is z direction. Okay, and this plane is your xy plane. Okay, xy plane. So I think it is a little bit hard to visualize, but I have tried to show you. Now let's come to a problem. एक problem कर लेते हैं ताकि चीजें और आंसर इजी हो जाए. प्रॉब्लम करें एक. So here we have a problem. The spectral line corresponding to an atomic transition from j equals to 1 to j equals to 0 states splits in a magnetic field of 0.1 टेस्ला. ओके, जब वीक मैग्नेटिक फील्ड बोला का मतलब 1 टेस्ला, 0.1 टेस्ला, इस 1 टेस्ला के आसपास ही रहेगा. ठीक है, इनटू 3 कंपोनेंट्स. Those are separated by 1.6 into 10 to the power minus 3 angstrom. Okay, if the zero field spectral line corresponds to 1849 angstrom, what is the G factor corresponding to j equals to 1 state? And you are given, you may use, this came in June 2012, hc by mu naught approximately 2 into 10 to the power 4 centimeter. And your options are 2, option B 3 by 2, option C 1, option D 1 by 2. So try to solve this question. Hello brave heart, Sahasi Hriday. Just write your answer in the comment section. So you have been given the spectral line corresponding to an atomic transition from j equals to 1 to j equals to 0 state, and that splits into a magnetic field of 0.1 Tesla. Magnetic field दे रखा है, J equals to 0 से 1 equals to J equals to 0 में ट्रांजिशन दे रखा है, and 3 components में डिवाइड हो गया. The separation is also given in terms of wavelength 1.6 × 10⁻³ angstrom. If the zero field spectral line corresponding to 1849 angstrom is lambda का वैल्यू 1849 है, what is the G factor corresponding to J equals to 1 state? Okay, इसको कैसे करोगे? मोनी सिंह बोल रहे हैं कि सी यस, सी ही होगा आंसर. सो यू सी द जीमान स्प्लिटिंग, what is the formula? I have already given you the formula of Zeeman splitting. Delta E equals to mu B into B into G into delta mj. ओके, ये वाला फॉर्मूला हम लोगों ने पहले दिया फॉर एनोमलस जीमान इफेक्ट. So delta mj, J equals to 1 to 0. So here we have to take delta mj equals to +1. Okay, so that is giving you G into mu p into B. So what is the Zeeman separation, guys? So the Zeeman is splitting, Zeeman separation. This is Zeeman separation is given to you. Delta lambda equals to lambda square by c into delta nu. Okay, and this is given to you 1.6 into 10 to the power minus 3 angstrom. Okay, 1.6 10 to the minus 3 angstrom, and the value of B is also given to you. So from here we can just find out delta nu equals to c by lambda square delta lambda. Okay, so c is 3 into 10 to the power 8. Lambda is given to you 1849 angstrom. 1 angstrom 10 to the minus 2 centimeter, 10 to the minus 10 meter. Delta lambda 1.6 into 10 to the power minus 1 centimeter, because 1 angstrom equals to 10 to the power minus 10 meter. Okay, so that is right, 10 to the minus 3. So this is 1.6 into 10 to the power minus 1. So this is giving you 0.1404 into 10 to the power 10. ठीक लिखा हम लोगों ने? So what will be the value of G? G equals to delta E upon mu P into B. Delta E is equals to 6.626 into 10 to the power minus 34H into 0.1404 into 10 to the power 10 upon mu B into B. Mu B is 9.27 into 10 to the power minus 24. B is given to you 0.1 Tesla. If you calculate it, you will get 1.00. So option C is the correct option for this question. मोनिक सिंह, ये थोड़ा सा करना पड़ेगा, मतलब ये जीमान इफेक्ट की क्वेश्चन में आपको थोड़ा सा कैलकुलेशन करना पड़ेगा, क्योंकि इसमें ज्यादा कुछ है नहीं, बट दिस विल गिव यू 5 मार्क्स. सो आई थिंक दिस 5 मार्क्स इज फॉर द कैलकुलेशन ओनली. फॉर दिस जीमान प्रॉब्लम 5 मार्क्स दिया जाता है आपको बस कैलकुलेशन के लिए, अदरवाइज इसमें तो कुछ है नहीं ना. हियर if you know the formula you can just do it right away, but CSR people giving you 5 marks, so you have to either remember few things, like as I have told you to remember this value if you want to avoid the calculation. EB by 4 pi m, C equals to 446.7 into B in M inverse. So in this way you can just remember few things so to avoid the calculation. नहीं तो आपको कैलकुलेशन करना पड़ेगा. You do not need to do exact calculation. I think you are quite mature enough to do this kind of calculation. I think you know how to tackle this calculation. मतलब हर चीज का लिए देखो 6.626 है, इसका मतलब ये नहीं कि आप 6.626 ले लो, इसको आप 7 के कॉम्प्लेक्स ले लो, ठीक है. तो ऐसे करके 9.27 है उसको 10 के आसपास लो, तो you get some approximate result. You do not need to find out the exact result. You have to find out some approximate result. In this way, calculations are done here. Okay, I think you know about these things. अब exact calculation is not possible in that time. सो यू हैव टू डू सम टिप, लाइक 1849 है, इसको आप 1850 ले लोगे तो उतना कुछ फर्क नहीं पड़ेगा, बट योर कैलकुलेशन विल बिकम इजी. ओके, बट डोंट टेक वाइडली अपार्ट वैल्यूज, लाइक 1849 है, आप इसको 1900 नहीं ले सकते, ठीक है, फिर तो मतलब ऑप्शंस बहुत डिफरेंट हो जाएगा. सो जितना रीजनेबल है उतना तक लेने की कोशिश करना, ताकि आपका आंसर एकदम डिफरेंट ना हो जाए. So I think it is clear to everyone. Now tomorrow we have one session regarding this. Okay, those who are applying for this, appearing for this NET exam, we have kept one class 1 PM on Unacademy learning app. Okay, special class. This is basically a special class. It is free for everyone. Just attend this class. Here I will be discussing the how to avoid mistakes. Okay, how to avoid mistakes while attempting the paper. I have already shared the links on our WhatsApp group, Telegram groups. Okay, so you can just download that, you can just get that link from the group, or you just go to my profile by searching my name, Sahin Sorifi. Okay, you just search my name, Sahin Sorifi, and under the special class section you will get this class. So tomorrow at 1 PM we'll be sharing this, and there also you can ask your any kind of confusion query. लाइट मोड में एक क्लास होगा, आपका कोई भी सवाल हो आप पूछ सकते हो, मतलब एग्जाम रिलेटेड बेसिकली 1-to-1 डिस्कशन होगा वहाँ पे. आई विल बी शेयरिंग सम टिप्स, एंड आफ्टर शेयरिंग दैट टिप्स आई विल बी टेकिंग योर क्वेश्चंस. आपको अगर कोई टेंशन हो रहा है या फिर किसी और चीज मतलब पूछना है अगर रिगार्डिंग द एग्जाम, यू कैन आस्क. So if you have time and if you want to attend that class, attend that class. And let me just tell you guys, if you are thinking of preparing for this exam, you can take Unacademy Plus subscription using our referral code PhysicsHub. Okay, Unacademy will offer you then 10% off, and a lot of benefits are there. You get daily live class, part length test, full length test, assignments, proper structured course, classes in Hindi, in English, both language, PDF of study materials also share, dedicated doubt clearing sessions after every 3 lectures, WhatsApp and Telegram groups for offline doubt clearing, and many more things you get. So you can join Unacademy today, and you can choose any of the plans. So if you are targeting for the upcoming exam, upcoming NET exam, it's not this exam, ये तो परसों ही है. नेक्स्ट बार अगर आप प्रिपेयर करना चाहते हो तो यू कैन टेक दिस 6 month, 12 month और 24 months डिपेंडिंग ऑन यू. अब जितना भी ले सकते हो आप ले सकते हो. एंड इफ यू अप्लाई दिस रेफरल कोड PhysicsHub, Unacademy will offer you 10% off, and you can watch all the videos, all of it. Okay, and using one subscription you'll be able to watch videos of all the educators. ऐसा नहीं कि बस एक सब्सक्रिप्शन लो तो मेरा क्लास ही देख पाओगे, सारे एजुकेटर्स के क्लास आप देख पाओगे. एंड मैं ऑलमोस्ट सारे सिलेबस कवर करता हूँ CSIR-NET फिजिक्स. सो आप सब्सक्रिप्शन ले सकते हो. थैंक यू वेरी मच गाइज फॉर ज्वाइनिंग द सेशन टुडे. इफ यू हैव एनी क्वेश्चन you can just give it in the comment section and try to answer them. And you can also join our WhatsApp group, Telegram group, and all those things. Okay, thank you very much guys for joining the session. See you in the next class. Bye bye.